Okay, let's continue. What defines 5G? In the beginning, when nobody really knew what 5G is about, a lot of people came together and said, okay, it's about data rate, right? But not only data rate. A lot of smart people they already understood that there's more than just data rate, right? One is the number of devices. So when the discussion started in 2014, there were 7 billion mobile devices. Actually, most of them mobile phones. And the expectation that differed a little bit about what is a mobile device or an IoT device in the future. And they said in 2022, so very soon in 2 years, we might have 500 billion devices. So we are coming closer now, and it's still a question how you count these kind of devices, if NFC devices are also part of that or not. But estimates are now between 100 and 900 billion devices in 2022. So if you think about it, then again, it might be a discussion about throughput, right? But it's not really that, because if you understand that there's a difference when you have 1 million devices sending 1 bit, than one device sending 1 megabit per second, which means actually it's the same throughput, but to coordinate that it has a lot of things to do in the network. So there's more than that, right? You need throughput, but you have to think about the devices. So what else do we have? A lot of people thought about the massive multimedia for big sport events, like here in the football stadium, where you can really actually sit in the stadium and have augmented reality, maybe watch the game out of the sight out of a player, or if it's too boring, about the ball itself. So there are some use cases that people thought that could be there. So massive multimedia. And for that, you need high data rate and big throughput again. And here we show one example of this kind of distribution of content in such a stadium. It looks like TV station in the old times, but it's a reliable synchronous multicast to 120 tablets. And here you see the camera. We move it around, and you see that the stream is perfectly conveyed to the devices very synchronously. But as you also can see, there's a huge delay, right? So whether this is really able to show something like the player or the ball, I think the sound effects in the stadium will not be the same. Good. So there was a definition about 5G from the IMT 2020. A lot of people try to explain what 5G is, and they also put together what we have seen here. They say it's a triangular thing, right? You have different use cases, and in one corner up here, you have the enhanced mobile broadband, right? So huge data rate. That's everything you need. Down here, they said you need massive IoT, so a large number of devices. And the other corner down here is low latency. So if you look at this, and you know that there's not only 5G, there's also 4G, and 4G with the presence of 5G will also evolve. 4G has a lot of potential to also at least destroy the market for 5G in the beginning in the enhanced mobile broadband and in the massive IoT device, because 4G comes already with narrowband IoT. It's not massive IoT, but a couple of hundred devices they can easily digest. So what is really unique to 5G is the lower corner here, the low latency corner, as we call them. And here it's important to see, why do we need low latency? I already addressed a little bit that you want like to have real-time control of the Internet of Things, machines, but also humans. So these two categories are important for low latency. You will see later why. If we go away from the IMT 2020 definition, we can go to the 5G atom definition that we have introduced here at the chair. And you can see it in the book chapter, where we say, okay, there is a new definition. It's a little bit more complicated than a triangle, yes, but the definition is based on two things. One are the use cases for 5G, and there are a lot of them, as you will see. And the other one are the electrons of the atom, where you see what do you need to do to support such a use case. And there we differentiate between requirements, concept, technologies, and innovations. But don't worry, it's not just a picture. We're going through this step by step. So first, the use cases. With the 5G Lab Germany together, we had a lot of industry contact and still have. And these industry contexts are very good because they're paying some of the PhD salaries here, but also they bring very interesting questions. And we have to solve these questions for them. And with that, we also define what the network should look like. So if you see here the core, the 5G core, you have a lot of the use cases. UC stands for use case. And if you look at them, things that we discussed in the 5G Lab Germany is about augmented reality, Industry 4.0, mobility and transport of goods on ground and in the air, healthcare, robotics, construction, energy grids. Sounds far-fetched, but even there 5G plays a role. Education of people, how to learn something, and agriculture. So you see, the list is not complete. Right? These are things that we have worked on, and there are a lot of projects that you can see here in our 5G lab. Maybe we can offer you a tour once everything is opened again to show some of these use cases here really working in detail. So once you have the use cases, you can ask, what kind of network do you want? And in the beginning, all of these industry partners, they thought they have a unique request for a network, but if you look into this in detail, they all want the same, maybe with a different focus, but the requests were more or less the same. First, we look into some of the use cases that we have for transport. For example, platooning was one of the things where cars can go on the highway step by step. If you would like to see this video running, go to the YouTube page. I will not start them here all the time. It shows you what would happen if you would have local control with only sensors, what would improve if you have communication among the cars, device to device, and what would improve if you have an overlay network, you see it here a little bit in the back, and the device to device communication. So what will happen? How close can they go together? When will be their crash if somebody has to stop unforeseeingly? Okay, then we had done something also with cars, transportation in the street. This is Barcelona. It's a demonstrator we did for Nokia on the Mobile World Congress in 2017, and very nicely done, where you can see the cars are going around over the street lights. Here, an example you will see later. And also human beings are here communicating using big multimedia streams. So also very interesting as use case. The Industry 4.0 use case where humans and robotics have to work together is another example. And here we have a remote training for a robot. So imagine you would like to have some skill set for this robot. You could maybe go there and fly over. For example, if this one is in Japan, you fly over, you have to program a robot and then he will do what you would like to do. But why not staying home in these days? Very reasonable. And then you just teach the robot what to do in a virtual world. The virtual world is a copy of the real world in Japan, and you tell the robot what to do. And just by showing him what to do, he will learn what his task is, right? So it's called Industry 4.0 training, another use case. Agriculture, there we talk about machines that are already available now, but also future machines, how they will look like. Maybe the machines will not get bigger and bigger, like also in computer science we had mainframes at a certain time and then we break them down to PCs. In the agriculture case, they also would like to do something similar, having smaller machines, but a lot of them. But then they need to be connected to not crush into each other and have collaborative work tasks. For the energy, we have here an industry or an energy grid. It's a fully blown grid where it's connected to the coal mine and later maybe to windmills. And we show how 5G can help here in case to build smaller and smaller smart grids in order to consume and to produce energy in a small area. So this has some effects, and how you can do this, there's a demo for that. Also here on the YouTube, you can watch that. But I have a more advanced later for you also prepared. There's one called the tactile internet that has something to do with the training of a robot, but here we would like to train humans as well. There will be one small video about the tactile internet in full. Now, I would like to take out the car scenario again, right? So cars that can be driven on the streets without that somebody has to use the steering wheel is an old dream, right? Here's a picture from the 50s where the family can sit and play a board game, and the car is just following a line on the highway, right? Maybe Dad steered it to the line and said, just follow the line from now on. The idea is not new, and we also looked into that, and why, the question could be, why do you need a network at all, right? Because in the car, they have already a communication network, and this communication network goes from all four wheels to each other. For a service like ESC or ABS, you need the latencies on these wheels between 1 and 2 milliseconds in order to make them efficient. Now, when they communicate the wheels, you can even think about the platoon. You have seen it before with the trucks. Now, if you bring them very close together with, let's say, 1 meter, 3 meters distance, then it's not only that the 2 wheels of one car or 4 wheels of one car have to talk to each other. Now, all the wheels in the platoon have to talk to each other, right? Question could be, do we need such a communication at all? Why don't we just use the sensors on board of a car and use that? And this here is a demonstration we some students built, 14 years old, Lego Mindstorms, following a line and understanding obstacles. So the first car sees something, will stay still, and the others will also stand still, but the others here will resonate, right? It's a classical known control problem. And you could, of course, improve the situation. And this is very easy if you lower the speed, or if you make the distance between the cars bigger. But if you make the distance of the cars bigger, the advantage of a platoon in using less energy is reduced and makes the platoon obsolete. And if you say go slower, then the problem is they will never reach the target as they wanted to. So just sensor-based is not good enough, but using sensors of others, that's interesting, right? So here you see our approach. We say we will have an overlay network, it could be a 5G network that talks to the platoon, and let also the cars talk to each other, right? And how this could look like is, for example, one of the very first presentations we had in the 5G lab Germany. And this is a slide from Gerhard where you can see the intersection, right? And now instead of waiting for streetlights, you just send in cars like this, right? So it's not very fluently going here. But normally the cars are going quite fluently. But you also have to deal with pedestrians going over the street and other things, right? You will see later also here the Frogger type going over the street that has no mobile phone, while the old lady might have had a phone with her. The Frog did not have it. But there are sensors on the cars that could have seen the Frogger. Okay, so how this could look like, I will show you here. It's a very nice video where you see some cars going over an intersection. It's a video we always use to convince people that 5G is a good idea. You also understand why there's not a big need for a steering wheel or a brake inside the car, because if people get nervous, there will be accidents, right? So this video was quite convincing for most of the people there. But of course, this is a trick, right? Was a guy sitting long times copying pictures into pictures, and to let the viewer understand that there are no accidents, right? And that this is a fake. You can see now from the last person going over the street, right? I mean, who would do this in a normal way, right? Okay, but it gives the idea how it should look like, right? And we built something like this again for a Nokia demonstration for Mobile World Congress in 2016. And we used real cars, small cars, so remote cars, and you can see they still follow the line. They have some sensors embedded to see the cars in front of them, but they cannot look to the left or to the right. And in order to not crash with the other cars, they send their position to a computing device that will always find out whether the car should go slower or faster. right? Something we refer later as a mobile edge cloud. And this demonstration was running for 4 days and was really spectacular, showing the idea of cars driving without human help, right? And it's not a scripted version, what you can see here. So if you just stop the car somewhere else, this has an impact on the cars in the back. So this means you stop a car, the next neighbors would stop right away. Others in the back might drive a little bit longer, but then they will also go slower, right? And this was all not only the cars and the, as you can see here on the top, this was a camera understanding where the cars are. This was driven by a mobile edge cloud at the time. So it was quite interesting. And if you bring this all together, as I showed you before, the Barcelona use case, now it's a virtual world. So you have humans with high data rate mobile phones, you have cars going over the street, and you could go there with your goggles, watch around what happens on the streets. You can even walk over the streets. And interesting is, you will see soon an accident. And with this accident, you have to first investigate this. So police or fire workers would send in the drones, and the drones are not only calculating and showing the fire workers what is there, they also bring some base stations, some network capabilities with it, right? And once everything is fine, what you will see is everything will go back to normal and the cars can go over the street again. Here it's important to understand how the police, for example, the fire workers, will take a big portion of the network at the time, right? Okay, we come back to that. As I said to you before, there are these wheels going into each other, right? If we talk about now, we can drive cars, then if you understand the car not only for transportation of people and goods, if you understand such a car is also a mobile base station, right? And it has batteries. So the parking of a car could also help to strengthen a mobile network just by putting the base station at the right point, right? But also if you think about the battery, it's not only loading the battery, maybe you want to discharge the battery of the car in a certain given scenario. Here we show it again. This is now a more advanced idea. Here you see the coal mine first sending energy. Now we don't have this anymore, but we have small grids, right? Here 3 houses on this side, 3 are here, and they will now consume a little bit more of energy. And what happens now is one car parked on the one side will move over to a different side because the battery is fully charged. And the moment it will park the car, it will now also contribute with the energy to this kind of cluster. So here you see the merger of 2 use cases. One is energy, one is our cars. And now if they come together, you need a communication network that can all control that, manage something like this. This tool is quite interesting, and you can also play around with it once you get access to the 5G lab. Okay, next point, 5G technical requirements, but let's make a pause first.